Hello, my name is Umair Hoodboy. I'm a product manager at Infineta Systems. Infineta provides the world's first and only 10 gigabits per second WAN optimization solution. In this unedited video, we're going to demonstrate a transfer of 252 gigabytes of data across a WAN both with and without the DMS. The DMS, of course, stands for the Data Mobility Switch, which is Infineta's flagship product. First things first, let's take a look at the network topology. The dark cloud in the center which is labeled apposite, is the WAN emulator. And in this transfer, we're going to do an FTP of 14 unique files. The servers on the left are the FTP servers. Each server has 7 unique files, so the two servers comprise a total of 14 unique files. Each file is 18 gigabytes in size. The data patterns on each of these files is similar to DB2 log format. And if you do the math, 14 unique files, each being 18 gigabytes in size, that makes 252 gigabytes. So 252 gig is what we're going to do an FTP transfer of. And we're going to transfer it from left to right, or in other words, from west to east. The setup is going to be analogous to a US coast-to-coast transfer. So think of the FTP servers on the left as being in San Francisco, and the clients on the right side are in New York. A few other things about this setup: we're using a 2-bridge system here, a 2-bridge setup. The DMSs are deployed inline, and both bridges are being used. So they provide 2 links to the WAN emulator, and each is going to be configured for that coast-to-coast round-trip time. The coast-to-coast round-trip time from San Francisco to New York is typically about roughly 80 milliseconds. And so that's what you see here on this WAN emulator. This is the WAN emulator. It's an apposite Netropy 10G, and we've injected a delay of 40 milliseconds at each end. So 40 milliseconds. The WAN pipe itself is 2 gigabits per second. So 80 millisecond round trip time, 2 gigabits per second. And as I mentioned earlier, we're using 2 bridges through the WAN emulator. So on the apposite, that is referred to as an engine. So engine 1 and engine 2 are configured identically. They both have a 2 gig WAN, and they're configured for 80 millisecond round trip time. So the setup, to summarize, is a 2 gig WAN, 80 millisecond round trip time. We're transferring 252 gigs of data from left to right, from San Francisco to New York. So let's go ahead and do our baseline test, which is an FTP of half of that from each client. So the 4 windows that you see on the screen right now, the 2 on the right, top and bottom, are the clients, just as in that diagram, and on the left are the servers. So I'm going to use wget to do the transfer, and it's going to use the FTP protocol. But before we do that, why don't we just do a quick ping test to make sure that we have indeed an 80 millisecond round trip time. 80 milliseconds shown there, and 80 milliseconds shown there. So both clients, each client is reporting 80 millisecond round trip time. So now let's go ahead and kickstart that transfer. Each client will fetch 126 gigabytes, 7 files each. So let's take a look at the WAN emulator. Okay. What we're seeing here is about 50, I'm going to call that about 50 megabits per second on engine 2, and on engine 1 if we drill down, it's also about 50 megabits per second. Another way to view that is on the DMS itself. If we go to the Interfaces tab, right now, of course, this is bypass traffic. It's not accelerated traffic. Each bridge is reporting about 48 megabits per second. That's the bottom pane. The receive rate is about 48, 49. I'm going to call it 50 megabits per second. That's on the first bridge, the top bridge. The bottom bridge is also showing about roughly 50 megabits per second. So 50 megabits per second on each bridge makes it a total of 100 megabits per second. So to recap, 100 megabits per second is the throughput that we're seeing when we're trying to transfer these files. 100 megs per second, but we've provisioned a 2 gig WAN. Remember, it's a 2 gig WAN, and each engine is 2 gigabits per second, but we're only seeing like a tenth of that. Okay. The clients here, each client is reporting an estimated time of about 6 hours, 45 minutes, close to 7 hours. And this being an unedited video, we're not going to sit and wait 6 hours for the transfer to complete. So I'm going to go ahead and stop it, stop both transfers. And let's go ahead and kickstart the same transfer, the FTP of these files with acceleration enabled. So we go to each DMS. This one you can think of as the DMS in San Francisco, and the tab to the right of the NetRTT, we can think of this DMS as the one in New York. So coast to coast, and right now what we're doing is we're turning on acceleration on both DMSs. Run that transfer one more time, now with acceleration enabled. Well, the first thing you'll notice is that the connection count on this dashboard, the bottom left corner, which is connection count, it goes up to 28, and that makes sense. That's what we would expect. If there are 14 files being transferred, an FTP session has a management session as well as a control session as well as a data session. So the data session is separate, and that's the one which is contributing to the high level of throughput. And we're seeing here a throughput of 9.1 gigabits per second immediately. The WAN footprint, however, is only about roughly 1.3, 1.2 gigabits per second. So here we're making better use of our WAN. Previously it was 100 megabits per second. It was 50 on each bridge. And now it is upwards of 1 gigabit per second. So we're making better use of that pipe. Remember, we had provisioned a 2 gigabit per second pipe, 2 gigabit per second WAN. We're seeing closer to that on each bridge. So let's take a look at the WAN emulator, the opposite. Each bridge now is seeing upwards of 600 megabits per second. So we're making better use of that WAN. That's engine 2. Engine 1 is also seeing about 600 megabits per second. So that's where we get the 1.2 gigabits per second on the WAN, total being used. Yeah, here we go. The WAN out is about 1.29 gigabits per second. LAN in, which is the actual LAN throughput that we're seeing, is upwards of 9 gigabits per second, 9.16 gigabits per second. So that gives you a reduction ratio of about 86%. Let's take a look at each of these transfers. We go to the connection details, you can see that there are at the moment 28 connections. Like I said, 28 connections, of which half of them are going to be the FTP control, the FTP management. That's what these source port of 21 indicate 21, all these 21 ports. But the other ones, the ones with the ephemeral ports, are the data, and that's where you see the high throughput of upwards of 600 megabits per second, about 650. Actually, if you do the math, 650 times 14 is roughly 9 gigabits per second. The reduction ratio is also shown here, about upwards of 80%, 86% to be specific. Let's take a look at any one of these connections to see how well they're doing. So 700 megabits per second, and they're each getting that fair treatment of a very aggressive throughput, very aggressive treatment in this being FTP. 700 megabits per second, only 100 megs being used on the WAN. And let's take a look at the clients themselves. They're reporting that they should be done any moment now, about roughly 20 seconds now. And here we go. Here we're seeing the end of these transfers. One by one they're finishing. So on average, each of them took about 4 minutes and 12 seconds, 4 minutes, a little over 4 minutes. 4 minutes, and previously it was north of 6 hours. 6 hours without the DMS. I think it was like 6 hours and 45 minutes, if I recall correctly. 6 hours, 45 minutes without the DMS, 4 minutes with the DMS. It hit 9.9 gigabits per second consistently throughout that transfer, and each connection got about 700 megabits per second, 650 to 700 megabits per second. This is clearly the only product on the market that can do this, that can sustain upwards of 9 gigabits per second for a across the WAN. In this case, it is coast to coast, 80 millisecond round trip time. If you have any other questions, feel free to visit our website, infineta.com, or contact us on Twitter at Infineta. Thanks for watching.